All right, everybody. Now we got a really cool part here, right? So we did points J, K, and L in the previous video, but now we want to tackle N, and N is where life gets really interesting, right? And so here's our situation, right? So I'm going to cut it off at some arbitrary point N. It's the distance X from point A, which I'll consider that to be the origin. We have the 200 pounds and the 25 pounds acting in here, and then we have a portion of this triangular shaped force. And this could be like snow on a roof or something where it's drifted, but it doesn't matter. However that is, we've got a portion of it. We don't have the whole thing. So we have to keep in mind the slope of this line is 100 pounds per foot, because that's the peak, minus 0 here. So 100 pounds per foot over 3 feet. So that's the slope of that line. All right, so we're going to keep that in mind because we're going to need this force in here. All right, so let's start off with the sum of the forces. I'm going to work over here. So the sum of the forces in the y direction, I've got minus 200 pounds plus 25 pounds minus v. All right, and then I've got whatever's going on inside of here. So keep in mind that as I'm working this problem, let me just kind of let me do this big here. So here is what I've got in this triangular portion, right? And this is X right here, but this thing doesn't start until 6 feet. So this distance in here is X minus 6 feet. That's the base of this triangle. Right, that's the base of the triangle. So that's the run. And so the rise is going to be the slope times the run. So this is going to be over here, a height of 100 pounds, let me just say 100 over 3 pounds per foot squared, and then times X minus 6 feet. Okay, so notice this is in feet and then 6 feet. So this will be pounds per foot when it's all said and done. And so what that means then is that the net force in there, just of the triangular section, so the total force of the triangular section, that's 1/2 base times height. So that's 1/2 the base, which is X minus 6 feet. This is very unpleasant, isn't it? That's just the base. And then the height is 100 over 3 pounds per square foot times X minus 6 feet. Okay, so that's pretty unpleasant. That's it. Yeah, I think we're good there. Okay, so that's going to be so 1/2 base times height. 1/2 base. The base is X minus 6 feet. Height, yeah, that should be good. I think we're okay. All right, so this is equal to 100 over 6, and that's pounds per square foot, and then X minus 6 feet squared. Okay, so there's my force inside of there. So there's the force inside there. Right? So I need to bring that in. That's pointing down. So minus 100 over 6 is 50 over 3 pounds per square foot. And then X minus 6 feet quantity squared. And so V is equal to, bring that over, so negative 50 over 3 pounds per square foot, X minus 6 feet, quantity squared, and then minus 175 pounds. So just doing a quick unit check here, X is in feet, so feet minus feet is feet, square that, that's square feet on the denominator there, so it goes away and you're left with pounds. So I'm pretty happy with all of that. All right. Okay, so there's the sum of the forces. Now I still need to do the sum of the moments. All right, so I've got some room issues, but okay, I'm just gonna put it right here. So the sum of the moments about A. So I'm just gonna go ahead and do M, and then of course that again, there's no moment there. 25 pounds, so plus 25 pounds times 3 feet. All right, and then minus V times X, and V is this lovely equation up here. I'm just going to leave that alone. I'm just going to keep it like that. But then I've got this force. Okay, now here's where life gets interesting, because we have to remember that the force is at the centroid of the shape. So the force is, say, right here. And that force is right here. Okay, so let's actually go ahead and put that force in, and that's going to be clockwise, right? So minus that force, which is 100 over 6, so 50 over 3 pounds per square foot, and then x minus 6 feet squared. Let me actually write that down here. I'm going to run out of room, I think, over there on that right. And that's squared. All right. Okay, there's the force. Now what's the distance? Okay, so the distance is right here. Well, this distance from here to there is 1/3 the base. So that distance is, let me call that Q for a second. So Q is equal to 1/3 x minus 6 feet. All right, so this is x. I got to come back 1/3 x minus 6 feet. So this position right here, right, this position is x come back 1/3 of x minus 6 feet. All right, so that's going to be x come back 1/3 x minus 6 feet. That is the distance this force is applied from A. All right, so when I do all of this, I'm going to get M, and I'm going to call that M sub n equals, I'm going to tackle this last. So I have 75 foot-pounds, and that's going to be negative, because I brought it to the other side of the equal sign. And then I bring this to the other side, it becomes positive, so plus, but then that's minus. So minus V, which is this lovely stuff up here. Let's see, pull that minus sign out. So 50 over 3 pounds per square foot, x minus 6 feet squared, plus 175 pounds. And all of that's times x, right? Because it's V times x. It's V times x, because that's where V is acting. But then I've got to bring this in, this lovely situation in right here. Bring that to the other side of the equation, that becomes positive. So I get plus 50 over 3 pounds per square foot. And then I have x minus 6 feet squared, and then what is this going to be? This is x minus 1/3 of x, so that's going to be 2/3 of x. And then minus and minus becomes plus. 1/3 of 6 is 2 feet, so plus 2 feet. And if we do a quick analysis on units, pounds per square foot, this is going to be foot squared, so that's pounds, but times the distance, so it's going to be foot-pounds. And then this is pounds per square foot. This is feet squared, so that's pounds, but this is all distances, so that's foot-pounds. And there's my moment. It's all of this loveliness right here. That's a nasty equation. And there's V. And we should discover, I won't do that in this video, but we should discover, if I take the derivative of this, I should get that. If I did everything right, So let me set that as an exercise for you. Take the derivative of this, and if I did everything right and you do everything right, we should get that for this year. All right. If you have any questions on this, please put them in the comments below. Thank you.